We're going to explain how to modify a Huggingface Data Collator to add an end-of-sentence EOS token to your sequences without padding them to a fixed length like 100. This is useful because padding wastes resources if your sequences are already shorter and you just need a clear EOS signal. 1. Understanding the default data collator. Hugging Face's default data collators often pad sequences to a maximum length. This is convenient for batch processing on GPUs, but inefficient if your sequences vary greatly in length. They usually operate on a list of dictionaries, where each dictionary represents a single example and contains your input IDs, input IDs. 2. Creating a custom data collator. To avoid unnecessary padding and add an EOS token, we create a custom class inheriting from data collator with padding, or a similar base class depending on your needs. 3. Adding the EOS token. Inside our custom class, we'll override the yeshom call sounds method. This method receives a list of dictionaries, one for each example in a batch. Within this method, before padding, or instead of padding if you choose not to pad, we add the EOS token ID to each sequence. Let's assume your EOS token ID is 2. We'll iterate through each example's input IDs, append the EOS token, and then proceed with the padding, or not depending on our strategy. 4. Padding. Optional. While we aim to avoid unnecessary padding, you might still want some padding to handle slight variations in sequence length. The data collator with padding already handles this efficiently, but you would modify its parameters for padding to use dynamic padding to only pad up to the longest sequence in each batch, rather than a fixed length like 100. The padding true argument in the data collator with padding is the default, and that's what we need to use. 5. Example code snippet. Here's a simplified code example, assuming you're using the Transformers library. Python from Transformers import data collator with padding class custom. Data collator with padding. Def call, self, features. EOS token IDs, EOS 2. Replace with your actual EOS token ID for feature and features. Feature input IDs in the feature input IDs. Plus EOS token ID. Adding EOS token. Return super. Call. Features. Initialize your tokenizer and model as. Use the custom data collator, goes custom data collator, tokenizer, padding. True. Hatch padding. True, but dynamic. In your trainer equals trainer, model, args, training, args, data collator, hash. Rest of your trainer arguments. 6. Important considerations. Remember to replace 2 with the actual EOS token ID from your tokenizer. This code adds the EOS token before the padding. If you don't want any padding at all, you can remove the super call features the line. However, remember that this might lead to inefficiencies if your sequence lengths are highly variable. Choosing between dynamic padding and no padding depends on your specific needs and hardware limitations. Experiment to find the best approach. Using dynamic padding often provides a good balance between efficiency and ease of batch processing.